So this manipulative is used for teaching students intervals in the music classroom. Now, learning to identify and sing along with intervals is something that many students will definitely struggle with in the classroom. And of course, it's essential for later skills that they're going to have to develop, such as harmonic dictations and identifying notes within a chord. So have a look at the manipulative first. So you can see here, it's a recreation of the monochord with a nylon string running. It's fastened at these two hooks. The string will resonate in the area between these two bridges, which are 30 centimeters apart, and that scale is written here, 30 centimeters. And I have a movable bridge which can be introduced to reduce the area of the string that's resonating. For example, and the reason I have these two bridges together is that so students don't push too hard and raise the frequency. So you just press down in between the two bridges, and when the string is touching both of the bridges, that's when the second frequency is going to be true. The tasks that I've created are built around the fact that Pythagoras found that the distance between the intervals could be discovered using simple ratios of numbers. For example, a 2-to-1 ratio produces a perfect octave. So a basic task would be to give the students a known ratio for an interval, say perfect fifth, which is 3-to-2, and have the students calculate where that would fall on the monochord. So they would calculate that the length of the string is 30 centimeters. So to get a 3-to-2 ratio, they would need 20 centimeters of the string to be vibrating. So they move their bridge to 10 centimeters to have 20 centimeters vibrating. And then they can test their theory out. And then have them sing along with each note. So, do, and then use solfege to go up to this note. Do, re, mi, fa, sol, do, sol, do. So they hear the interval first. They can sing up to the interval using solfege, or sing the interval using solfege. They're hearing it and then they're consolidating it with their own voice. This exercise can also be done in reverse by giving the interval first and then having the students find what the ratio is. So give the interval perfect fourth, for example. So you hear the tonic, and so the students have to sing do, re, mi, fa. That's the note they're looking for. Fa, fa. And eventually they'll find it. And it's with 22.5 centimeters resonating. So that gives a ratio of 30 to 22.5. And then ask them to simplify it, which gives a ratio of 4-to-3. Just to make it a little bit more challenging, you can compound this exercise. For example, have them find the interval first, for example, of a major third, which is at a ratio of 5-to-4. So they'll know that 24 centimeters, 30 to 24 equals a ratio of 5-to-4. So that the interval of a major third should be found at 24 centimeters resonating. So then have them find a perfect fifth of this note. This is the new tonic. So they know that out of 24, they need to find a 3-to-2 ratio. So they'll calculate correctly that it's going to be 24-to-16 is a 3-to-2 ratio. So I find here, so I'm looking for the perfect fifth of this note. Do, do, re, mi, fa, sol. That's my note. So then they've just compounded their exercise. Finally, an interesting concept for the students, a consonant interval, such as the perfect fifth, will produce, the 3-to-2 ratio produces a simple decimal, such as 1.5, 3-to-2. Whereas a dissonant interval, minor second, will have a complex decimal. So the ratio is 15-to-14, which produces the decimal 1.0714285. So, and to understand this dissonance, have the students use their monochord. So for the perfect fifth, have them sing the open string while the monochord plays the other note. So they sing do. So you can hear it's not hard for me to hold that note, whereas in a minor second, so this is my note, and this is the note here. So I'll sing the original note. It's quite hard for me to hold that note. And so just to represent that the consonance produces a simple ratio and the dissonance produces a very complex ratio. Thank you very much. Just to reiterate that the intervals, learning intervals, for some reason, it stumps a lot of students. They just cannot get their head around it. And often in the classroom, a variety of different methods are used and tricks are used for the students to learn their intervals. And this is just another fun way and using numeracy to learn the intervals.